Hello everybody. We're going to talk about triple integrals in cylindrical coordinates and spherical coordinates. This part is from section 15.7 and 15.8. Let's first look at cylindrical coordinate, the definition. So we're talking about triple integral. In other words, the domain we're going to take integral is in the three-dimensional space. And suppose you have a point P in three-dimensional space, then we can usually we used to write three numbers x, y, z, and x, y, z. Those three numbers stands for x coordinate, y coordinate, z coordinate, which is called Cartesian coordinate. So by three numbers x, y, z, we can identify the where the point is. But now we are going to provide different way to identify this point, which is called cylindrical coordinates. In cylindrical coordinates, we still need three numbers, r, theta, z, but they have different meaning. But there's for the third component z, this is the same as z coordinate, so which is the point, the height of the point from xy plane. So which means if you project this point to xy plane, then the distance, the length of this red line is z. So the height from xy plane. So z is z after transformation. But r and theta, they have different meaning from xy. So what is r theta? It is indeed polar coordinate of this projected point in xy plane. In other words, r is the length of the projected point to the origin, and theta is the angle formed by x-axis and this projected line. So basically x is the same as r cosine theta, and y equals r sine theta. If we recall the polar coordinates in two-dimensional or double integral, then we have this. So again, we can write it's Jacobian, but for this case, we have simple, we don't need to look at the Jacobian. So usually we have the triple integral is looking for dx, dy, dz, right? But dx, dy in polar coordinate is replaced by r, dr, d theta. So that means we don't change anything else, but dx, dy can be written as this and dz. Also, we have r squared equals x squared plus y squared, which comes from these two. And tangent theta equals y over x. So the transformation itself is this, but from transformation we can write it's Jacobian, right? And also we have some identities which sometimes simplifies the calculations. So here is the conclusion. So triple integral is defined by Riemann sum, but we can write this in cylindrical coordinate, which is f dz and dx dy, which is replaced by r dr d theta. All right, now we talk about another definition to identify any point in three-dimensional space, which is so-called spherical coordinates. So we need three numbers. Still, there's no way we can reduce the number of components no matter what coordinate system is. So in Cartesian coordinates, we have x, y, z, which stands for x, y, z coordinates separately. But rho, phi, theta in spherical coordinates also identifies the same point by having different meanings. So what is rho? Rho is the distance from point to the origin. So rho cannot be negative, it's a distance. If rho equals 0, then this point, and the point is exactly the origin of the coordinate system. And what is phi? Phi is the angle from this red line to this z. So you can think of something like this, an umbrella. So if phi equals 0, then this this one is somewhere here. So somewhere here. So it agrees, it's on the positive half part of z-axis. And if this is phi, then it is something like you are going to open the umbrella to a certain angle, right? So if you get this, then the umbrella has the surface something like a circle. Right. And what is theta then? Theta is the red line. If you project to xy plane, then the angle formed by this projected line and x-axis, which is theta. So we can still write rho, which is not part of rho phi theta, but it it gives what's the distance of the projected point to 0, right? So we can first write rho by, if we look at, so if we look at this triangle, this is orthogonal, then maybe this is not a good way to write orthogonal, because this is, we are going to write this way. So suppose this is orthogonal, then from this triangle you can see that R is going to be this R, and because this is phi and this is rho hypotenuse, then R is rho sine phi. And z, this is z is the height of this point from xy plane, which is z. Z is rho cosine phi. Now we can look at x here. So because x is r cosine theta, so x is r cosine theta, which means from here, if we replace r by rho sine phi, then you also need cosine theta here. This is x. And y is similarly r sine theta, but we can write this r sine phi and cosine, no, sine theta. So that's basically gives the transformation x coordinate, y coordinate, and z coordinate. And let's look at what it says. So we have r equals rho sine phi, and x is here, r sine phi cosine theta, and y is rho sine phi sine theta, and z is rho cosine phi. All right. Now the question is again, what is Jacobian? Because we know that dx dy dz is going to be Jacobian, which can be written as xyz partial rho phi theta, right? And d rho dv d theta. So this is Jacobian, and this guy is the same as the determinant of 3 by 3 matrix, which is x rho, x phi, x theta, and y rho, y phi, y theta, and 0, z phi, z theta. And we can calculate what x rho is. So from here x equals rho sine phi cosine theta. Take the rho derivative, then it is sine phi cosine theta. And for x phi is rho cosine phi cosine theta. And maybe I need more space for, let me move this here. So, and x theta is rho sine phi sine theta, but negative sign. And similarly, we can write y rho. Y rho is sine phi sine theta, and rho cosine phi sine theta, and rho sine phi cosine theta. And the last one, z. For the z part, we can look at here. And rho derivative is cosine phi, and phi derivative is negative rho sine phi, and theta derivative is 0. And this is 3 by 3 matrix, and we're going to skip the computation. You can do just first row co-expansion, or maybe third row co-expansion we can figure out, but the after calculation, this determinant is rho square sine phi. So that's why this box will be replaced by rho square sine phi when we calculate a triple integral using spherical coordinates. So let me first skip this into here. So this is the triple integral formula. This is triple integral f dx dy dz is the same as triple integral of after transformation the region, and of this h is f after substituting corresponding x, y, z, and rho and dx dy dz is given by rho square sine phi d rho d phi d theta. Rho square sine phi is given here because our previous calculation gives Jacobian as this rho square sine phi as this term. And here, let me write h here. So how we get h? So this is f x y z originally. Then after substitution, x is replaced by this, y is replaced by rho sine phi sine theta, and z is rho cosine phi, and this is called h rho phi theta. All right, now we are going to look at this object. There's a spherical, so we want to know what is spherical coordinate equation for the cone z equals square root of x squared y plus y squared. So if we have x, y, z coordinate, the equation of this cone is given by this formula, which is a little bit complicated equation. But if we look at any point here, any point in the cone, then this point have phi equals pi over 4. And that means the cone equation is basically phi equals pi over 4. Rho can be anything. Rho can be anything greater than or equals 0. And theta is anything from 0 to 2 pi. So the point is that for some 3D object, we can simplify the equation by using spherical coordinate, but not for any shape, for the shape which fit into spherical coordinate. All right, let's look at one example, which I guess this the only example in this in this discussion. So find the volume of ice cream cone D, which is given by here, cut from the solid sphere rho less than or equal 1. So rho less than or equal 1 is a solid, it's a ball with radius 1. So by the cone phi equals pi over 3. So we can imagine that there is a ball with radius 1 and which is cut by this umbrella with phi equals with phi equals pi over 3, which is 60 degree. So the cone is like this. So for this problem, we can use the volume formula. So the volume is basically triple integral 1 dv, right? And this is triple integral rho square, excuse me, sine phi, and then d rho d phi d theta. The problem is, what are those 6 expressions, upper lower limit for each one? So what is d rho? D rho is rho range. So if you just shoot a beam from this point origin to the sky into the ice cream zone, then it starts from 0 and it ends escape from this ice cream at this point, which is exactly on the surface of this ball, which has radius 1. So rho is basically changing from 0 to 1. In other words, rho minus is 0, rho plus is 1. All right. Now, what is d phi? What is change of phi? Phi is, we can think of this ice cream just like umbrella. So you can gradually open this all the way there. So gradually open this all the way there to the edge. So phi is from 0. 0 is the angle overlaps with z axis, and all the way to pi over 3. Pi over 3 is the edge of this ice cream. And what is theta? Theta is basically, we can think of anything. So this is theta. So anything in the from 0 degree to all the way, take a circle. So that means theta is from 0 to pi, 2 pi. So this gives me, so I write this a little bit bigger, and rho square sine phi d rho d phi d theta. And for rho, it's inner integral, and the second layer is from 0 to pi over 3. Third layer, the last one, is 0 to 2 pi. So this is the formula we have to calculate for the volume. And we do this from inside. So that means outside I will just copy and d phi d theta. But if you calculate this part, then sine phi has nothing to do with rho, right? When rho change, sine phi stays the same. So we can take this out from integral, and inside is rho square, so it is 1/3 rho cube, which is antiderivative, and put 0 and 1, take the difference, which is 1/3. Okay, and then we do this inner integral, which is second layer. Then if you calculate, then this is 1/3 1/3 1/3 cosine phi, but negative sign, and put 0 pi over 3, right? So this is negative 1/3 negative times cosine phi is 1/2 minus negative 1/3 cosine 0 is 1 d theta, and this is negative 1/6 plus 1/3, which is 1/6. Now at the end, this is multiplied by 2 pi, which is pi over 3. All right, so that's the answer. And all right, the last page. The last page is the summary. So we can have cylindrical domain, which is x equals r cosine theta, y equals r sine theta, z equals z. We can have spherical domain, which is this. And under cylindrical, we're not going to talk about this, and it won't be tested in final, but so for Cartesian domain, we have dx, dy, dz. And for cylindrical domain, we have this formula where here r is Jacobian, comes from here, these two. And then if we use spherical domain, then we have Jacobian like this and 0 dv d theta. All right. This is the end of this video.